Okay.
Hello, everyone.
Well, hello, Larry.
Good to see you, friend.
You too. It's been a long time.
All right. Do we have any preferences as to what order to do things in today? Do we want to do the business part first and then Martin's presentation, or vice versa?
Yeah, go ahead with get your business done.
All right. Does anyone have any updates or corrections for last month's meeting minutes? Can anyone other than Martin hear me?
It's good.
Okay.
Loud and clear.
Scott does a great job.
Is his otter thing connected?
Yes, it is. About 2 minutes ago.
Okay, I will
He
write
put it in
down.
the wrong time zone, and it started about 3 in the morning.
Okay. I'll indicate there's no corrections or updates. All right. I do not have anything to report. But as I recall, there was a couple of items that I brought up last month that we should get to in old business. So we'll get there when we get there. Brian, do you have anything?
Just 2 things. One is, if you haven't already, please put your name in the chat. Just put in your name and call sign. Makes it easier to track who's participating today. And then one thing, and ask, we need a presentation for the April meeting. We've been going after someone for several months and haven't been able to get it to work yet. So if someone has an idea of a presentation for April, please let me know. May is taken care of because it'll be the barbecue on Orcas. But we do need an April presentation, so please let us know. Thanks. Back to you, Larry.
All right. And somewhere I have the treasurer's report.
And Ed has a connection to it, so he can go ahead and take care of the whole thing if you want.
Okay.
How's that look? Can you see that?
Yes.
Okay,
Yep.
great. I'm gonna spin this thing around to the treasurer here.
Hello, everybody. There's the treasurer's report. And we have now 96, 95, and 54 cents in our bank. And the amounts there for where it says Orcas Picnic and San Juan Picnic, those are reservation amounts that we needed to pay to hold the venues for our picnics. So we're all set to go for both of them. Any questions? Okay.
All right.
See on the membership?
For Ed to say.
Yeah.
Yeah, it's 68 and increased by 5.
Excellent.
And
Okay, Larry, it's yours.
I understand that the renewal of the club call sign has been taken care of now.
That is correct. Sometime back, and that
Here of last month.
last month, and that means Echolink is back working again.
All right. Anything happening with E? VE?
So I believe there's going to be one in San Juan in May. I haven't heard for a date yet. I'll have to go into that. We don't have anything planned right now on Lopez, but you never know.
Okay.
And see, of the 4 people who got their license, I know one of them already has their radio and is on the air.
Okay. Repeaters, Ed, is there any news on the Katy site?
No news. I did, I had a chat with Alan, Wednesday, and he said that the, Frank's sister is really, going to try and, let us keep the repeater there on Katy. So if it's at all possible, so, um, I'm trying to, I think maybe Alan's gonna set it up to let me talk to the agent, the real estate agent, which is this sister's son, about exactly what the repeater is and how much electricity it uses and so on, so that if he's showing the site to somebody and they say, what the heck is that? He'll be able to sort of answer the question.
All right, I guess the best effort we can make without being overly intrusive.
Yeah, I think that's right.
Okay, and while we're at it, Ed, is there any news on the EOC project?
It's proceeding slowly. We're working out some details. The main project is to get the telephone poles up and get the antennas on the telephone poles. And so, I've been working with, and so's Wayne, with, Dave Halloran, who's kind of honchoing that thing. And, it's looking like maybe June, we should have antennas.
Okay. All right, I think we discussed last meeting that we're trying to see if we can get somebody from ARRL to present to us regarding spectrum defense. I haven't heard anything back. I probably need to ping my ARRL person and see if they have any updates. I can't remember where we left the in-person event on San Juan. I think a date was set and a location was set. I don't know what else is required to wrap that up.
About the VE,
No, this was the one that Matt was talking about. You know, the in-person meeting for July on San
right.
Juan.
Well, they have the reservations, both of them are in place as far as I know, on Arcus and San Juan.
Okay. I
And
think
they're on
Matt was
calendar.
spearheading that. And I don't know if Matt's here today. Probably not. We would have heard from him by now. And Scott did get the reservation for the Orcas picnic for May.
Yes, on the Saturday.
Yep. Okay, and the business I brought up last month was that Dan had made a reservation at Jackson Beach Park for the 27th of June, and we kind of decided that was too close to field day to swing it. But Dan is holding an event there anyways, the monthly coffee gathering, I guess, on San Juan. And my motion was to reimburse Dan for that as kind of a one-time thing. Do we have everything we need to vote on that at this point? There was no quorum at the meeting last month.
I agree.
They've both already been reimbursed. That was in the treasurer's report.
Well, in that case, my motion is moot.
And he just moved the date. He had one reservation and he moved it to the July 1.
Okay,
So no money was lost. It was just moved to a different date.
okay. All right, well, I guess we need to drop that motion, and the last question is there any other new business? Hearing nothing, I assume that there isn't. And we could maybe, at this point, switch over to Martin's presentation.
Just before we do this, I'm going to ask once again, people who came in late, if you'd put your name on the chat, just put your name and call sign so we have information on it. Thanks very much. Looks like Martin just walked away. Probably getting more coffee.
I have a calendar correction.
Okay.
On the club calendar at SJCARS WordPress shows the ham lunch in Friday Harbor on the 23rd of May, and we are holding that on the last Friday of the month, so it would be the 30th.
Okay, thanks very much. I'll change that.
Thank you. And that's a repeating last Friday of the month event.
Okay, last Friday. Yeah, I may have got my arithmetic wrong.
Okay, thank you.
Okay, Martin. I can read it.
Is he muted?
Martin, I'm not hearing you.
Yes, I was muted. Sorry.
Got you. Thank you.
Okay. Good afternoon, good morning, whichever applies to where you currently are. I'm going to be talking to you about a project that I started a little while ago that kind of grew out of something else. I started working on my next generation repeater controller, and I was interested in supporting more than analog modes. And it occurred to me that we have a need to start thinking about digital linking as opposed to analog linking, because current day requirements for repeaters include things like digital mode, telemetry, simple messaging, and other digital modes that are not being catered to without putting an internet connection at a repeater site. We always have the mantra that when all else fails, amateur radio prevails. Well, if we're dependent on the internet for our repeater systems and it goes down, then we're obviously, that's not going to happen. So I started working on this project, and I reconnected with an old friend of mine by the name of Steve Stroh. And Steve and I had many conversations until we started talking about the 400 meg band and how it's currently underutilized, mostly for repeater links and so on. And what can we do to bring mesh networking to the 400 band? And then it occurred to me that that would be a very good solution for intra-repeater linking with multiple paths, backups, redundant connections, and so on. So we started exploring this. Okay. So that's picture, by the way, was taken from my backyard. Okay, so let's move on. So what is this project? This is a project to explore digital networking in the 400 band. As I said, the repeaters and links are currently underutilized. This particular frequency band has good propagation and penetration characteristics, as opposed to the other digital stuff that's being done now on 2.4 and 900 megs. If you get a tree in the way, you're out of luck. So we have a band that is underutilized that we want to start using for more things. So part of this project is to use off-the-shelf modem components. There are a lot of chipsets being developed by a lot of different manufacturers now that we can make use of. And wireless transmitters in off-the-shelf parts are becoming extremely commonplace and extremely inexpensive. So it's time that we started thinking about what we can do with it. So our minimum bitrate goal for this project is 100 kilobits per second. And we have a bandwidth goal to go to 2.5 megahertz and have higher data rates. Now, I realize in the States you're limited at the moment with what you can do in certain bands, but there are some other solutions that we can look at as we go on. So the goals of the project to start simple. Let's build a transceiver using off-the-shelf components and hardware and explore what we can do with it. Develop simple firmware to build a simple mesh network. I want to have a flash it and go approach. No administrator involvement, no setup involvement, no having to join a network and one guy, I happen to be working today, so I'm going to do it tomorrow kind of thing. No, get it off the shelf, put the firmware in, off you go. Then develop further, develop a hat for the Raspberry Pi. We're going to add networking and routing layers. We're looking at Batman and Babel as candidates for that. Experiment with higher order modulation methods. I'm specifically interested in doing OFDM. We do not have an amateur service currently that's using OFDM on air. So that would be a first. And obviously overlay audio, video, and data services as well. So to get started, here's a simple evaluation node. It's an off-the-shelf transceiver built by ST Microelectronics. It's an STM32WL33, and this evaluation board is available from a group of different distributors, Mauser, DigiKey, and so on, and cost about $45. And it even comes with a built-in debugger. This thing can do up to 600 kilobits per second natively using 4FSK. It's got 100 milliwatt transmit output, and it's got a minus 115 dBm sensitivity. It has a dual UART, so we can talk to it and put a little menu in it and so on. And it has support for an SPI plus a debugger and everything else. It also has the Arduino connectors, so you can do things like put GPS receivers or anything that's built on the Arduino platform will fit on that as well. And the software development is a free download from the ST Microelectronics website. Moving on, the next generation will be a Raspberry Pi hat node. This is a 3D rendering taken from my CAD package. And I actually have, those boards were shipped yesterday. So I'm going to have them in-house here next week, and I'll have them populated and operational by the end of the month. This uses a UART connection to the Pi, implements TTY AMA0, and we got flash and EEPROM updaters so you can update the firmware. The processor underneath here is exactly the same. It's an STM32W033. And using this connector, we can attach a debugger or a GPS receiver or virtually anything you want to attach with a UART. Then we have a module. The module is self-contained. It measures 14 millimeters by 20 millimeters, so it's smaller than an inch each way. It's based on the same processor, and this can be integrated into any project very easily. I have a footprint for it that's can be hand soldered, and those are on their way at the moment. They're being manufactured now. I should expect them in about 3 weeks or so. And then we have a thing called a supernode. The supernode is a new repeater controller. Now, the object of this exercise is to be able to support existing analog repeaters and also provide for the digital modes such as M17 and MMDVM modes. M17 is particularly of interest to us because it's entirely open source. And even the codec is open source as well. And I don't know how many of you actually have been on DMR, but we describe the audio from DMR as Donald Duck on steroids. And but the codec 2 used by M17 has a very natural sounding, has good compression. So in order to get repeater audio down to a point where we can transmit it on a 100 kilobit per second link, we will compress it using codec 2. It takes it down to about 3.6 kilobits per second. This will support 2 repeaters, 2 radios, either mode. It'll auto detect between MMDVM and analog modes. It's based on it has an FPGA, has a high-end SD micro device, has an Ethernet connector, a GPS receiver, a USB for configuring, and these are the 2 radio ports, and this is the audio section over here. This is a piggyback connector where we can attach various different modems to it. So that we're expecting to have up and running by later on in the year. This is an OFDM modem module which plugs on top of that board. It does both an 420 to 450 or 902 to 928. And it also does 2.4 gig as well. So notwithstanding your bandwidth curve considerations, we could always do a cross mode where we use 400 for the low speed, within the regulations, 900 for the higher speeds, using an OFDM modem instead. The plan is to have a dual mode protocol. Basically, it consists of a 4 FSK carrier and OFDM data carriers to either side of it. So using the full bandwidth will be 2.56 megahertz. That will give us up to 5.8 megabits per second on air. And the lowest common denominator being the 4 FSK carrier in the middle. And what I've done is I've punched a hole in the middle of the OFDM to enable a higher bandwidth, lower speed carrier to coexist with the OFDM symbol as well. So the plan is that when 2 stations talk to each other to establish a session, they'll bid for bandwidth. And as they bid for bandwidth, if they're both OFDM capable, it says, well, let's go to full bandwidth. If we're using a supernode and other ones people are connected in as well, we can actually share this bandwidth. So certain carriers can go to one station, certain carriers can go to the other station. And it's using FDMA as opposed to TDMA. Is everybody here familiar with this? Put your hand up if you're familiar with OFDM. Okay, no, not one. Okay, so let's pause here a minute. OFDM stands for orthogonal frequency division multiplexing. And think of it as the closest analogy is a trunk of copper used by the phone company. Coming to your house, all you need to make one telephone connection is 1 pair. With 50 pairs in a cable, you can make 50 connections at once. Now imagine if we have one carrier, i.e. my 4 FSK carrier in the middle, I can only carry on one conversation to one station at once. However, if I have multiple carriers spaced evenly apart over a wider bandwidth, I can now either send data on all of those carriers at the same time, or I can send one carrier to one station, one carrier to another station, another carrier to another station. This method is used by cell phones. It's called LTE and G4, G5. And it's actually been around since the 60s, but it wasn't until probably the late 90s did we actually have horsepower, enough horsepower on silicon to be able to do it inexpensively. So the shrink in size of silicon has enabled more complex modes like this. In the amateur mode, we're stuck with in the middle here, using things like quadrature amplitude modulation and other methods to achieve, and using high bandwidth with a single carrier, as opposed to using high bandwidth with multiple carriers and modulating those with a fairly lower order modulation. The lower orders allow for better signal to noise ratios and better propagation characteristics and the ability to put error correction in as well. So we'll always have the 4 FSK carrier in the middle. So the little Nucleo board and the Pi hat will always be able to do that. The OFDM mode will require something a little bit more complex. But that's the end goal of the project. The software model that's used is called the OSI, Open Systems Interconnection 7-layer model. Basically, at the bottom here, we've got 3 layers that actually do the physical, get the thing on the air. And then at the top here, we've got application layers that decide what they want to put on the air. And in the middle, we have a thing called the transport layer that connects the upper layers to the lower layers. Down in the lower layers, first of all, we have a physical layer, which consists of our FSK modem or our OFDM modem. Above that, we have a frame layer. And the frame layer does things like generating a beacon frame. Hello, I'm here. I'm capable of doing this. I have this much power. I'm located at such and such latitude, such and such longitude. Frame repeating. If you send me a frame and want me to repeat it, I'll repeat it back out. And a mesh table generation. Who are you? Okay, I'm going to put you in my table. I know who you are now. I know how to get to you. In the network layer, we do things like putting in routing tables with dynamic routing. Now, in an internet network, we talk about IP addresses, and everybody has what's called an internet protocol address, which is something you rent for a while. And if I want to send a message to you, I say, send it to this IP address. And then the network's got to figure out, well, where the heck is that address? And so it goes looking for it. And once it finds it, it says, now I know where to send it. It sends the data to the other address. In this particular case, amateurs don't work with IP addresses. We don't really care about that. We work with call signs. So if I want to send a message to Larry, for example, I just want to be able to stamp a packet, send it to NM7A, send it out over the network, and let the network figure out how to get it there. And that's called the network layer. We have a couple of candidates we're looking at. One is called Babel and one is called Batman, which are popular network discovery and routing protocols. The supernode layers are mostly to do with repeater control. In the application layer, we have a full-blown repeater controller, which controls analog repeaters, and MMDVM is an acronym for multi-mode digital voice modem. It supports basically anything that's C4 FM based. So Yaesu System Fusion, D-Star, DMR, NXDN, and M17 are all based on the same physical protocol. So the presentation layer will do things like transcoding and MUA law PCM compression. So we'll start with something like analog FM, for example. We'll digitize it, and then we'll compress it into an M17 packet. And the session layer looks after things like, okay, I want to start a session with you. Somebody pushed his mic button on that, and the repeater picked up a signal. Now, where does it want to send it to? and how does it send it, and how does it establish the bandwidth. And this is where we'll do things like establish the bandwidth and carry on with things like, are you capable of doing higher bandwidth than 100 kilobits? Oh, you are. Okay, how much bandwidth can I have? And for example, also another example could be, say you want to do a file transfer, for example. So your application layer will be something here that's going to be reading a disk and sending a file. And well, if you're going to send a file and it's a big one, you want to bid for as much bandwidth as you can get. But if you're just sending a little audio file, for example, you don't really care about it. In the supernode, using it as a repeater controller, I can either coexist or replace existing controllers. We're going to fulfill the new digital demands of the repeater. So we'll be able to do analog, PCM coded, AMBI or M17 codec, telemetry measurements, APRS reporting, simple messaging, cross-mode repeating, M17 to analog and vice versa. And we'll have built-in redundancy. The mesh topology for linking allows multiple routing channels to get from point A to point B. So if your link goes down between 2 points on a mesh network, you can find another route to get there. So your link may go down or may be obstructed or something else may have happened other than a hardware failure, but you can always find another route to get from point A to point B. And the number one goal is remove reliance on internet and low power wireless ISPs. The analog repeater controller is actually up and running. I published this in CQ Amateur Radio back in 2016. It uses what's called a finite state machine. And the finite state machine is something that can exist in one of many different states. Something happens on the outside, it changes states and does a particular action. So, for example, we start up here in a sleep, and all of a sudden we get a carrier. Oh, okay, now let's go send the ID. And when we send the ID, we'll now start going to an active mode. When he lets the key mic go, we'll go to a tail state where we'll send the go-ahead tone. And if he doesn't hit the mic again, then we'll go to a state where we'll stay idle for a while, eventually send an ID and come back to sleep again. If he's too long-winded, we go to a timed out state where we shut the transmitter down. And when he comes out of that, we'll send him a little thing like TONCW to say, hey, you timed out the repeater. This I have up and running on about half a dozen different repeaters at the moment. And the enhancements we're making for this is to be able to do CW or voice ID. There's an SD card on the supernode controller where the audio files can be stored. This is a telemetry encoder. Now, telemetry is a way of measuring remote voltages remotely. So we can measure battery voltage. We can measure things like your PA current. Is your power amplifier putting out full power? We can measure, if you're using solar power, for example, we could measure what's your solar charge rate. And there's 8 digital inputs and then 5 digital inputs and outputs. So connect one to a magnetic switch on the shack door, and somebody opens the shack door, boom, it'll send you an alarm and say, hey, somebody's breaking into your shack. And then one of the outputs could go to a siren. So open the shack door and the siren goes off. Or we could do things like a variety of different other contacts, or do things like if the PA gets too hot, turn a fan on. And all that automation can be remoted to something that listens to telemetry, decides what to do with it, and sends something back again. I have all that stuff up and running at the moment. So our roadmap for the project is to start with phase 1, which is do a simple frame layer and a mesh table and a chat application. The second phase is to connect a Raspberry Pi using the SPI, and that's actually the code I'm trying to debug right now. So we can develop upper layers and more complex applications on a Raspberry Pi. And the third phase is to build the SuperNose hardware, move into the higher modulation orders, do a new playhat for OFDM. Current status, phase 1 code is up and running. It's available on GitHub. The phase 2 Raspberry Pi is planned for release April 2025, which gives me about 20 days to finish debugging my code. It's written, but it's not released yet. My Pi hats are in development at the moment. I'm expecting the first couple next week. And my modules are actually on order, and my manufacturer says it'll be about 3 weeks before I see them. The SuperNode's not announced until later on in the year, simply because there's a lot of development effort that has to go into it. And our first repeater installation that's going to use this technology is a 900 megahertz machine, which is going up the end of Q2. And we're going to have it linked on the Arden network. It's also going to have a MMDM upgrade, and the first IP400 link will go in probably Q2 2026. Why is there such a time lag? It's because it's kind of cold around here in Q1. You don't want to be climbing towers. Okay, so sum it all up, it's a project to explore mesh networking in the 400 band. You can get started to play with it with a very simple eval module. You can build up a node with a Raspberry Pi and a hat module. And the SuperNode at the repeater sites adds the MMDVM capability. Our linking is going to be able now to support all the various different modes, telemetry, SMS messages, and everything else. It's open source, will always be that way. Any contributions you may have are more than welcome. And that's it. Any questions? Did I lose anybody? If so, do you want me to back up to anything?
No, I think very interesting stuff. Yeah, I'm a little bit familiar, having been following, what Steve Stroh's been writing about it.
Oh, okay.
I have just sort of a geeky hardware question. I think it was a repeater controller. You mentioned using an FPGA on that.
Mm-hmm.
I'm curious, is there any particular high-speed stuff going on inside the FPGA?
Yes, there is. Two things. First of all,
I saw DTMF and decoding.
There's a DTMF decoder in there.
Okay.
It's a Gertzel algorithm DTMF decoder. There's also it's controlling a couple of analog devices. Codecs that have a very particular bus all to themselves.
Okay.
So it provides a FIFO, so I can read and write the FIFOs to the codecs. It also does CTCSS generation and detection. So that will that uses a fractional sign lookup table to generate those. So it's adding that in as well. So just the audio, digital audio gets written to the FIFO, the CTSS gets added, and that's what gets transmitted. Likewise, coming back in, there are bandpass filters for the audio and for the CTSS as well, which are all FIR filters. And because of the roll-off, they're fairly lengthy. They're about 500 samples. And also the detection of the C4FM, the modulation of C4FM, and detection of the MMDVM frames all in the FPGA. And by the way,
that makes excellent sense.
Yeah, all the high-speed stuff is going to go in there. So the object of the exercises, the processor I chose is a high-end ST Micro that runs at 500 megahertz. And so the thought being I'll bring bring a set of analog samples in. The standard seems to be 20 milliseconds of speech, which is 160 samples. Bring those in, run them through the codec 2. It comes out as 8 bytes, believe it or not. And then that kind of bandwidth can be sent over 100 kilobit per second link very, very easily. And of course, the codec will be integrated because the codec is open source. The downside of the Ambi codec is it's only available from one source. They are in limited supply right now, and you have to buy basically one of these sticks in order to be able to use it. So you need a full-size USB connection in order to be able to do it. And the FPGA I'm using is a new kit on the block. It's made by a company called Efinix. DigiKey has the 20K gate array listed for less than $10.
Wow, what's the name of that company?
It's Fefinix.
Okay.
It's I think it's a Korean company. Interesting enough, one of their major investors is Xilinx. And Altera's or Intel's has kind of disappeared off the face of the map recently when they realized that their experiment to accelerate their servers wasn't going to happen with FPGAs. I was interviewed by Intel in Portland a while ago, so I had a little bit of inside information as to why they did that. And this one's come out. It's looks like a good FPGA. Tools are free. Free download. They're written in Python. The entry price to play with it is just to buy an eval module, which is fairly inexpensive, and you get support for a year out of it. So far so good. The only missing from their tool package is the simulator, but I still have the models and came with the other. By the way, what you can see on your screen right now is a menu. It's actually running on my Nucleo board right now. If I look at my mesh, it's my mesh table, for example. It's seen another station, which has this call sign.
So not seeing that.
I'm not sharing my screen.
I'm seeing it here on the
Yeah, I'm still sharing.
the sunrise picture with the tent.
Yeah, you can see it. It's the one that looks just like a terminal window
Yeah.
there, Brian.
Yeah, it is. It is a terminal window. It's a putty window. Yeah, you can see this is my desktop.
Oh, now we're
No, it
seeing
just
you,
went
but-
away.
Yeah.
Okay. How about now?
Yep, it's back.
Yeah, I'm seeing it on my tablet. Okay. So this is a little menu that's running on the Nucleo board.
Oh, now I see it.
Yeah, and this is all included in the software that's on GitHub. You can do things like this is looking at the mesh table. So it's found one station so far, and it stores things like what's the next sequence number for duplicate removal? When did it last hear it? How many hops did it take to get there? What are its capabilities? What's its transmit power? What was my receive power? So this was the RSSI when it received it. This is done by setting what's called a beacon frame. I've got some, set the radio parameters, for example. I can set my radio parameters this way. Set the frequency, data rate, and everything else. I list my current settings. I'm running on 445.75 with 4FSK at 100 kilobits per second with a peak deviation of 25 kilohertz. And my channel filter bandwidth is also, all this stuff is programmable and supplied by the manufacturer. Code is on GitHub. It's under the our society, which is the Alberta Digital Radio Communication Society website. I was just looking you guys up. Thinking it might be fun to take our trailer over there this summer and come and visit you folks. So if you go to this site, ADRCS.org, you might see that looks somewhat familiar.
Yeah.
There's a thing on the project here, and there's a link here to the GitHub repo. And there's a fair amount of documentation here as well on that you can download and take a look at, and all the code is here as well. I have two platforms, one for the Raspberry Pi and one for the Nucleo. Raspberry Pi one, it is not working at the moment because I don't have working hardware right now, but I'm still working on it. And one last final thing I should probably show you is You. This is the module. It's a 4-layer, multi-layer, complete with castellated hull, and it has the processor. And believe it or not, that thing, little part right there, is the transmit receive coupler that came from ST. And so that can be easily put onto any project. And this does the FSK mode. So that's really all I had to say.
One thing caught my eye at the very end is that it connect to Ardennes. And
Yes.
Unfortunately, where our location is here, we can't really see them, the one on the nearest one. And it would take a lot of panels across the county here to get to everyone. But if it was connected to a UHF repeater, it might be a way to get us into Ardennes. Is that possible?
It would, yes, but don't forget, you're looking at very small bandwidth.
Right.
As opposed to the larger bandwidth on Arden. I know the guys on the Vancouver Island have a mesh network because I helped them put it together. And are you able to link to it at all? Can you see or hear it?
Which one is that, please?
It's the Vancouver Island mesh.
Oh.
It's in main hub. I think it's all mostly RF based. Let's go back to this here. Zoom out a little bit. No, they're not at that end of the island. That's the problem. That network is, let me share this again.
By Campbell River or something, or Comox?
No, it's actually up by Ladysmith.
Mm.
Tell you what we'll do. When all else fails, go to the website. Yeah, so you guys are fairly way south of there.
Right. And
Look.
There's one in the Bellingham area or east of there, but we can't see them, or very few places can.
Interesting.
I'd think you'd be able to hit Salt Spring Island. They've got, looks like it's on the high part of Salt Spring Island too, so.
Yeah, let's see. He's got he's using his an RF connection on 5 gig.
Huh. Yeah, I can get them on UHF, a repeater there.
Yeah, but like you say, you really need something down around this area in the middle to make it work.
And if you see where Lopez Island is on the map there,
Lopez
look at that
Island?
green line. Yeah, I'm at the bottom there.
Oh, really? Down
and
here?
I can get, right at the bottom there. And I can get Salt Spring on VHF.
Mm-hmm. What you would be able to do is link repeaters digitally on 400 and stay within your current FCC regulations to anybody on the Vancouver side.
Hmm.
They also have a Hamlin network as well.
Yeah.
I know there's one in Bellingham, but that's not a flash it and go network, unfortunately. Yeah, Steve's just over here in Bellingham.
Yes.
He's actually down in New Jersey right now at Hamsai.
So Martin, are there any regulatory issues with this? Like, how do you coordinate if you have a fully loaded, system that's 2.5 megahertz wide, how do you coordinate that on a 440 frequency plan?
We actually used the spot that was allocated for analog video. That's 6 megs
Okay.
wide. Yeah, there's nobody's doing ATV around here anymore. So one of the things we can bring to the table with a wider bandwidth is to be able to do DTV instead. And rather than using the the ATSC standard, if we look at something like H.264 or H.263, which has much lower bandwidth requirements, we can get back on it. In fact, that's the way in the States where you can get away with doing highest bandwidth on 400, is if you carry a video signal, it's an exception for you to use higher bandwidth. And Steve is working on what he's calling a special transmit authorization in order to see if we can get an exception to send higher speed data. I looked at the FCC regulations, and yeah, as he calls it, a little archaic. But maybe this will give him some impetus to change it.
Yeah, that was the point I
That's
was
if
going
they
to mention.
that's if they still have any employees working there anymore.
That's okay. They're going to just get rid of all the regulations and then it won't be an issue anymore.
Cool. Off we go. Okay, so let me do a little bit of show and tell. Stop the share here. So sitting on the bench over here, there's one of the Nucleo boards, complete with its antenna. And that's the one I was showing you the menu from. This one over here is connected via an SPI. Whoops, no, wrong side. Here we are. This one's connected via the SPI to a Raspberry Pi right now. And I'm actually debugging the code that talks back and forth across the SPI. Here's an example of one of the early Pi hats. Now this used a module that we got from a company called eByte in China. And unfortunately, it doesn't work because they implemented the circuit for the high-speed oscillator incorrectly. So that's what prompted me to build my own module. Basically, it's just a copy of that one, but mine actually works. And then over here we have, that's one of the telemetry encoders. It's been nicknamed PUTSI for a PIC USB telecommunication system interface. And this works directly with All-Star. So it'll enable All-Star to, over USB. If you're running an All-Star repeater, you can get, it talks in Allison's voice. It'll give you the telemetry with the DTMF codes. It also has a Wi-Fi port on it, so I can get a digital frame out of it to another device somewhere using ESP8266 or whatever. And there's another Pi with my, this is my All-Star machine actually, with my FPGA-based controller sitting on top of it. It's doing all the physical control, and the Pi's doing all the DTMF processing and everything else.
Okay, how many pins does that FPGA have there? That's a lot.
That's 144. That's
Okay.
actually that's an Altera Max 10.
Okay.
But it's not what I'm going for. Those things used to be like $12. And if you look them up these days, they're like $70 a piece now. It uses an old mixed RAM flash process that Intel has basically shut the line down on. So they've upped the price to discourage people from, and they're saying they're not, quote unquote, not recommended for new designs. I gather you have an FPGA background.
Me, yeah, well, I've done some work in the 100 megahertz region inside of clock rates inside FPGAs. But no, it's really fun seeing the OFDM in use. I did design work back in the early telephony ADSL days.
Oh yeah,
familiar with that style of modulation.
I'll have to show you. Up on my wall here,
Yeah, and
My
how
wall-
do you
my
get your
wall of
lab so
shame.
neat? That's what I want to know.
Leave it that way. That is my first prototype for the OFDM transceiver that used 6 Xilinx 4000 series. That was its successor that used 2 Vertex, and that was its successor that did everything on a single ASIC. And that's what I did at a company called Wylan, where I worked for about 5 years. And we did that's my cell phone data receiver prototype, built by 3 Student Power.
Huh.
That was my very first ASIC back in the
Let's
80s.
see. I can show you. Yeah. Here we go. Here's my first ASIC, right? Which
Oh,
one
cool.
is it? Yeah, that one there.
Yeah. What process
Back
was
in the
that on?
2-micron days.
Oh, that one was 3.
Okay.
So you did that probably early 90s, right?
Yeah.
Yeah.
Early 90s, early to mid.
Yeah.
And a lot of other stuff since then.
Now we're
But
down
I've
at
been
10.
retired. Actually, I've been retired for 25 years now. So,
Oh, good for you.
but I'm spending more time with electronics now than, having more fun than back when I was getting paid for it. So anyway,
Yeah, I know the feeling. You're doing your own board layout?
yeah, just using KiCad.
Oh, good. Which version?
I'm depending on which computer I'm on, it's one of the Rev 8s.
Okay. I've just started on Rev 8.
Yeah, it seems.
I'm a little
I've
bit
seen-
annoyed with the transition process because all the library names have changed and all the component names have changed.
Yeah, I maintain my own library entirely for that. But even then, when you do an update, I got to go and change all the,
Yeah.
tell it where to find my library files. But yeah, I don't like people changing libraries underneath me, so
Yeah, things like the older version, an 0603 resistor suddenly became a 0603 underscore 18 something or other metric. And so you got to go back through the part selector and change all of that again. It's no big deal. I mean, but
yeah.
it's
I mean, and my own library, the more stuff I do, the more things I add, the more unwieldy it becomes. But still, for me, it's better than fighting with what somebody else, somebody else made.
true. The good thing, I guess, is that they do support the older symbols as well. So if you have an older symbol library, or I'm having issues with step files, the 3D renderings don't always seem to want to work properly. But anyway, if you want to jump in and help out, you're more than welcome.
I've got so many projects on my plate now. It's kind of tough. I should actually be at HAMSA right now, but I've got other things. I've got doing the FST4W transmitters and receiver stuff. So got some custom stuff I've designed. One's running down in Antarctica right now. So
interesting. Well, I might even come out your way this summer. I've never been to that group of islands. I've been to the other islands around it.
Beautiful, beautiful spot. You'd be welcome.
Yeah.
Even though you are, now our enemy apparently, but or 51st state, one or the other.
Oh God.
Paul,
My protest mug.
You will be assimilated. Don't worry.
Paul, we just need the German chancellor to come over here and redraw the line.
Yeah, it worked pretty well last time.
Well, the treaty was struck between the UK and the US in 1846. So go dicker with the Brits, because they're the ones that made the dividing line.
If you come out here in the summer, time it so you can. We have a pig war picnic every year.
Oh, really?
Yeah, to commemorate, and we've got actual Canadians come, and we treat them nicely.
What time of year is that?
It's summer. I don't know. Do you guys remember exactly when? No, well, we could find out. But
We'll
yeah,
probably
parade.
later
like
in
to know that.
August because I typically go down. We have a local hamfest in Montana in the third week of July, so we typically drive down to that, and then if we're going anywhere further in the States, we'll just go west on I-90 from there, and then head towards Seattle. I guess the ferry. There is a ferry from Bellingham. There's a ferry from Anacortes as well.
Anacortes is the one is there one from Bellingham? I know we all go on Anacortes as far as I know.
Oh, I think
Barry.
the Pig War Picnic is associated with 4th of July.
Ah, well,
I
that's
think
easy
that's
to
when it
remember.
happens.
Unfortunately, that's right in the middle of our stampede. And I will be in my airplane in the stampede parade.
Yeah, Martin, on San Juan Island, I think they have two historical sites. One's called British Camp and one's called American Camp
Oh, really?
from the war.
Anacortes is an island?
Yes, it is.
It's on Fidalgo Island.
Oh,
But
interesting.
there's a bridge to that island from the
Yeah,
mainland.
it's close enough to the mainland that there's just a short bridge to connect it.
Yeah. Oh, okay. Interesting.
Yeah, for those who want to contact Martin, his email, you can find it on QRZ. We
It's
don't put it
simple.
on
It's
our
my,
website.
it's simple. It's my call sign at mycallsign.org.
Okay.
And there's also a contact form on the ADRCS website. Some of my other less esoteric projects are on my personal site. Try to keep that reasonably up to date. That's about it, I guess. Interesting. I guess it's cheaper to take a ferry in the States than it is on the Canadian side.
Yeah, but there's
yes.
actually run.
Yeah.
What about dragging a trailer or something? Is that doable?
Yeah.
Yep.
That's
Yeah.
more expensive. You'll get a overlength surcharge.
Yeah.
Yeah.
If you're looking to do that, contact one of us because you need to get a reservation or you'll never get on. You have to get a reservation in advance.
Yeah, it's basically the same with BC ferries now too.
Right.
Unless you take the 4:30 a.m. ferry,
Yeah.
which I do sometimes.
Yeah, I'll be pulling a trailer with my wife still asleep in it.
Yeah.
They charge us, and BC ferries charges over length and over height.
Same here.
Yeah, is it? Okay. So
They have
it's
to
like
put you through the tunnel. They
it's
call it the
300.
middle of the ferry is the tunnel.
Yeah. It's about $300 each way.
Yeah. My wife has a horse trailer, so we deal with that.
Oh, yeah.
Yeah.
But you don't get the over height, right?
We charge
yeah.
on any measurable parameter.
Yeah.
Let's do it in microns just for interest's sake.
Yeah.
It
Yeah,
is.
and they'll come out with a measurement to be sure you're not fooling them.
Yeah, I know. They come up with the wheel.
Yeah.
The guy goes down like this, you know.
And they have
Oh, you're right.
stick,
It is a little.
to measure the height, one that makes the right angle.
Mhm.
And anyway, it's okay when it runs.
Yeah.
I've got an 18 AVT mounted on the bumper of my trailer,
It is
which I take apart.
here because they only charge one way. They only charge westbound.
Oh, really?
Yeah.
So going home is free.
Yeah. We want you to go.
So if I went by BC ferries to Vancouver Island and it went eastbound, I wouldn't pay the ferries, what you're saying.
You can't get there from here.
Not
Because-
anymore.
Oh,
Not in
really?
the last 7 years.
Yeah, they're predicting that the service to Victoria will restart in 2030.
30.
2030.
There used to be one that went all the way from Seattle
There still
to
is,
Victoria.
but it's not a car.
No, it wasn't because we pulled a trailer on it.
Not anymore.
Well, the
No,
current one's passenger or foot traffic only.
Is that the Clipper?
Yeah.
Yes,
Yeah, I know that one.
it's fun.
Yeah.
There's also.
There is one to Victoria from Port Townsend,
Yes,
or Port Angeles, pardon me.
Los Angeles. Yeah.
Blackball, but getting there from here involves another ferry, so.
Yeah, well, I've done that. I went to Port Townsend a while back, and stayed in stayed at Fort Worden.
It's
And
a
went to
beautiful
visit.
area.
Yeah, went to visit the site of an officer and a gentleman.
Exactly. Yeah, I
Yeah,
took my parents there. They really like that.
was that right? Yeah, we
Yeah.
camped right. We went on a campground right by the ocean. It was great, and the weather was great the whole time we were there as well. That was a little bit of a hike,
Yeah.
and it was interesting because we drove to Port Angeles and did a whale watching tour. And right out in the middle of the channel, we ran into another one coming from the Victoria side. So I said, "Well, we'll just hop out of the boat and go home that way." Okay.
Great. Well, thank you very much for joining us today.
My pleasure. I wish you well. And Larry, stay in touch.
All right,
Give my regards to Janet,
I will do so. Thank you.
and we'll take care. We'll talk with you soon.
Thank you,
Bye now.
Martin.
Wow, that was interesting.
Yeah, no, the difference, I'm still kind of a HF person, but what you can do up at VHF, what you're allowed to do, even here, is so much different. I really hope that we can kind of normalize and simplify our, the FCC rules and restrictions.
I can't remember what's happened in Canada, but I think they've gone to I think the Europeans have done this generally, where they just basically say, here's the frequency, here's how much bandwidth you're allowed, and here's how much power you're allowed, and that's it.
Yeah, I don't know. I guess we've got a large contingent of people who want to just do what they've been doing, and they don't want anyone to potentially interfere with, with the old ways of doing it, or whatever. But it would sure be nice to have more flexibility. At least we got a little bit more in the HF band, so we did, with the symbol rate the baud rate versus bandwidth change recently. But there's more to be done, I think. Modulation formats and protocols and things like spread spectrum. I'd like to see that opened up.
Well, there are places like Blinn Mountain over near Squim that should be able to see Vancouver Island and that area nicely, to be able to connect with Ardent, and then repeaters there analog wise should be able to be seen are able to be seen in the San Juans very nicely.
Yeah, what was that, a 5 gigahertz link? One of those was.
I think
anyway.
so, yeah.
Anyway, no, it's it's kind of nice to see this working kind of at the protocol level, designing this essentially from the ground up for, flexibility and interoperability, and, just a full networking design. That's
He had
really,
mentioned
good stuff.
D-Star in there, and I'm wondering, and Larry, you probably have some ideas. Would this supplement our current setup here, or would it augment it, or would it be applicable at all to our D-Star repeater?
I don't know. I mean, it's kind of like it would be kind of like a proxy, where if you could do the software, you could receive D-Star data as an input and send it back out somewhere else as an output, but the the system that Martin's talking about would just be a carrier in between, wouldn't have anything to do with D-Star.
Okay, because I thought he was talking about D-Star signals though. But most of these go right over my old head, so you know, I pick up a few words here and there.
Well, at some level, it's all just bits, and then the trickery is interpreting the bits.
Yeah.
Well, thank you for pulling together this month's meeting. I'm glad I was able to attend here. Really appreciate it.
It's really nice when you reconnect with someone from back in the day.
Yep. I think I told Brian this before, but I first met Martin in 1986. He was my roommate when I first moved away from home. So at the time, his personal computer was a PDP 1134, which was the size of a furnace. And he was building repeater controllers with EEPROMs.
Smart guy.
Yep.
Excuse me.
Any other business stuff, or can I control or stop the recording? Any other business stuff to do?
I didn't think we had anything left.
Yeah.
Okay, I'll stop the recording and people can just chat.
Yeah. I'm gonna go get some steps in. Thanks for the meeting.